we're going to look at a question on electrostatics. So just a bit of revision. I thought we need to start revising our grade 11 work. So remember, all your grade 11 content is tested in the June exams and in the final exams. So we need to keep on top of all this grade 11 work. So don't forget to revise and don't forget to start early with your revision program. All right, so this question also comes from a question from the Mpumalanga prelim paper and from social media. I gathered that some children were a little bit confused with it, so let us have a look. So the first question from this electrostatics question was to define the term electric field at a point. So once again, that is just your definition, and your the electric field at a point is really just the electrostatic force that is being experienced. So it's the electrostatic force, I need to select my pen. So the electrostatic force at or being experienced. Oh gosh, all right, I'm really not winning here today with the eraser. So it's the electrostatic force that is being experienced by a positive. So it's the force being experienced by a positive unit charge. So very important that we don't forget to mention that it's a positive unit charge. So remember, all your definitions in electrostatics were designed around positive charges. So everything is given in terms of a positive unit charge. So your electric field at a point is about the electrostatic force that a positive unit charge will experience. The next part is looking at to draw an electric field pattern around a particular charge. The charge they've given us is a -4 × 10⁻⁹ Coulomb charge. So we know that positive charges, all right, the field radiates out. Because remember, all our definitions were given in terms of positive charges. For a negative charge, to answer this question, the negative charge is the opposite. So all the electric field lines move towards the charge. Now be careful when you are drawing this diagram. Don't be too haphazard. So these lines enter at 90 and they leave the surface at 90. So make sure that your lines touch the actual charge. Also remember that we can't, when we are looking at these lines never ever cross. So you could put in more lines than what we have done. So you could put in a couple more, and there we go. So that would give you the marks. So this is the direction. So the direction of the electric field is moving towards the charge, and then they need to touch the surface, and they're always entering the surface at 90, or they're leaving the surface at 90. All right, so those are easy marks. They say to us here that the magnitude of the electric field at point P is now 3e. So let's go to the next question. And there it is. So point P is 5 centimeters. So here's P. It is 5 centimeters from charge Q, as shown in the diagram below. And they say the electric field at P is E to the left. But they told us, if we just go back to the previous question quickly, they told us that the magnitude of the electric field at point P is 3e. So let us just carry that through. Oh gosh, there we go. So it was originally 3e. All right, so let's just try and extend the page here. All right, so they told us originally the electric field at P was 3e. Now they're wanting us to, where's the next question? All right, we just need to go find the next question. And there it is. So the question says, calculate the number of electrons added to the sphere. Now on your information sheet, you're going to be given n is equal to capital letter Q over small q. This big Q is the total charge on that charge, and it was -4 × 10⁻⁹ Coulomb, and the charge of an electron, so this is actually the charge of an electron, is -1,6 × to the minus 19. So you will get this value off your information sheet. So if you go onto your information sheet, you will get that value for the charge of 1 electron. It's minus 1,6 times 10 to the minus 19. Now if I take the total charge dividing by the charge of an electron, you will then end up with the number of electrons. So now we're going to go and calculate. So on our calculator, we're going to go, we can leave the negatives out. So you can obviously see the negatives are going to disappear like my calculator just did. So we're going to go 4 exponent. So remember this times 10. Oh, there goes my calculator again. So that times 10 is actually just the exponent key. So you just press this exponent key on your calculator over here, minus 9 divided by 1.6 exponent minus 19, and we should get our answer. And that is the number of electrons. So it's 2,5 times 10 to the 10. So that is the number of electrons that were added to the sphere to get a charge of minus 4 times 10 to the minus 9. Now remember, a number of electrons, there will be no positive or negative sign because it's just a quantity. So this is a huge number of electrons that were added. And remember, the electron has a negative charge. So by adding all these extra electrons, we're going to get a negative charge on that charge Q, and it was minus 4 times 10 to the minus 9. Right, so let's go to the next question, and it says calculate the magnitude of the initial charge on the sphere. All right, so this is going to be a higher order question. So originally, always start by writing out the equation. So E is equal to KQ over R squared. Now this equation talks to electric field intensity. So they gave me E in the question, and they told me E originally was 3E, etc. And so that is my electric field strength, or you could call it your electric field intensity. So one and the same thing. So because I'm working with electric field strength and electric field intensity, I'm going to be looking at this equation. So write down the equation because you get 1 mark for writing down the equation. Right. So they say now the charge that was added, all right, is now added to charge P. So we're going to have a look. So we're going to have 3E is equal to K, the constant. So we want to know what the original charge Q was. We added this charge of negative 4 times 10 to the minus 19. So that was the new charge. And that new charge was experiencing an electric field of 3E. Over the distance they gave us as 5 centimeters, so change that to meters. So how do we change from centimeters to meters? We got to divide by 100. So it's going to be 0,05 squared. All right, so there's our first equation. And there we go. Now we know that originally this E here was equal to KQ over R squared, which was 0,05 before we added the electrons to it. So that was my original one. Sorry, it mustn't be a squared there. This is the squared here. And it's equal to K into Q minus 4 times 10 to the minus 19 over 0,05 squared. Now this looks a little bit complicated, but it's actually not too difficult. So remember, we're going to apply a few basic maths principles. So we're going to look to what is common on the left and the right and try and cancel them out. So if I have a look at the left hand side, I see yes K, so that K can cancel with that one, and I'm dividing by 0,05 squared, so that can cancel out with that. So now it simplifies it quite nicely. So I've got 3Q equal to Q minus 4 times 10 to the minus 19. So that is a whole lot simpler. So now we just do some simple maths, and so now we can take Q across. So we're going to say 3Q minus Q equals minus 4 times 10 to the minus 19. And so we've got 2Q equals minus 4 times 10 to the minus 19. So now we just divide both sides by 2. So the original charge Q was minus 2 times 10 to the minus 19 Coulomb. And there we go. So with these questions, I think there's a lot of we need to just pay attention is, are we working out electric field intensity or are we working out electrostatic force? I find there's a lot of confusion with those two concepts, and learners tend to make or choose incorrect equations. So electric field intensity, we're going to use E equals KQ over R squared. And when you are working with electrostatic forces, you will work with F equals K Q1 Q2 over R squared. So if you can just differentiate the question and that you don't do the incorrect equation, you should be fine with this section. So just remember to go learn your definitions, know the difference between electrostatic force of attraction and electric field intensity, and practice, practice, practice.